This tape is on Chapter D. Operations on monomials. Factors are usually found as parts of a single number or expression. Factors are multiplied together to produce a product or an indicated product. For example, in a number such as 15, the factors are 5 and 3. And the product is 15. Factors, product. Another example. 9x squared y z. The factors are 3 times 3, x times x, y times z. Another example. X multiplied by a plus b. The factors are x and a plus b. Next, a term. A term is a single expression which can be as simple as a number only or as complicated as a combination of numbers and variables in a product and or quotient. For example, these are all terms. 3 minus 5, a minus 5x, 5a cubed, minus 2a to the 2/5 b cubed, mb squared a, 6 over a, 4x squared over 3yz cubed. Brackets can make a term look rather complicated, as in 4 multiplied by a plus b, or minus x cubed subtract y squared, or 3x squared y multiplied by a squared minus b. If you look at this series of examples, we refer to each of these as terms again, even though they look a bit more complicated. When an expression consists of several terms, you can sort the terms out because they are separated by positive and negative signs. For example, 3 plus x. 4x cubed minus 2y. 7x followed by 3y minus 1 and plus 2y followed by x plus 1. Looking at the overall expression in each of these examples, here is a plus sign separating two simple terms, 3 and x. There are two terms in this expression. Similarly here, we have a minus sign separating two terms. Now here, we have two terms again, and the plus sign separates the two terms I have listed. You have to look at the overall expression in order to identify terms properly. Now, if you look at this particular term, 7x brackets 3y minus 1, of course, if you ignore the rest of the parts of that expression, you can identify two terms inside the brackets. But because it's enclosed within brackets, it's considered as a single unit together with 7x. So this, therefore, is a single term together with this one, which is also a term. And again, as I explained, terms can be identified by looking for positive and negative signs which separate them. And there's the positive sign which separates those two terms. The next word is monomial. A single term expression is called a monomial. The next word is binomial. A binomial is an expression containing two monomials or two terms. The next word is trinomial. A trinomial is an expression containing three monomials or three terms. The next word is multinomial. A multinomial is an expression containing more than one term. You probably have noticed that there is considerable overlapping of the use of these nouns. The next word is polynomial. This is a very specialized expression with specific application in mathematics. Continuing with the explanation of a polynomial, it is an expression which contains one or more terms, but each term contains the same variable, and that's an important distinction regarding a polynomial. They are often referred to as a polynomial in one variable. Polynomials are usually written in ascending or in descending order of powers. For example, 3 minus 2x plus 5x squared minus x cubed minus 8x to the fourth minus 3 halves x to the fifth plus the square root of 3x to the sixth, and so on. We would say that these powers are written in ascending order. We could rewrite this polynomial in descending order of powers by switching the terms around. And consequently, the same example representing the same polynomial could have been written in this fashion. X square root of 3, x to the sixth, minus 3 halves x to the fifth, minus 8x to the fourth, minus x cubed, plus 5x squared, minus 2x, and finally plus 3. In a polynomial, the exponents of the variable powers are always natural numbers. This constant term is sometimes called the absolute term. The number 3, the constant term 3, the coefficients of each term can be any real number. Here we have the coefficient of x, which is 2, negative 2. Here it's positive 5, negative 1, negative 8, negative 3 halves, a rational number, and the square root of 3, an irrational number. Each variable or each term can be any real number. The size of a polynomial can be described by its degree. And in the example, the degree of the polynomial is 6, which is the highest, the largest exponent of the given expression. The degree is the largest exponent of the given expression. And as I said, Here's another example. 2 plus 3x minus 4x squared. The degree here is 2. Here are a few other examples. 5x plus 7x to the 4th minus 3x to the 7th. The degree here is 7. The next idea I want to present is a polynomial in two variables. If 5x to the 4th minus 2x cubed y plus x squared y squared minus xy cubed, and finally plus 2y to the 4th. Notice in this polynomial that we have two variables, x and y. Notice that if you ignore the y variable and imagine them removed from each term, the x variables are written in descending natural number order of powers, whereas if you imagine the x variables removed, the y variables occur in ascending natural number order of powers. And so we're going to emphasize this idea by using a different color here. If we look at this expression and ignore the y variable, you will see that the x variables are written in descending order of powers. No x term occurs here beside the 2. Remember, x to the 0. But now if you ignore the x part of the expression and concentrate on the y, you will see that the y values, or at least the y powers, are in increasing order of powers. And that's how polynomials in two variables have to be put together. One other noticeable property of a polynomial in two variables is that its degree is the sum of the exponents of the variables within a given term, and that each term has the same degree. The degree of this variable is 4. The degree of this one, which is the next term, is the sum of 3 and 1, and that's 4. Similarly, the degree of this term is 4, and so on. So another property is that in a polynomial in two variables, the degree of each term is the same, and it equals the sum of the exponents of the variables. Here are other examples. I want you to write in the correct order. This polynomial in two variables, minus 3xy squared plus x cubed minus 4y cubed and plus 7x squared y. It doesn't really make any difference which particular letter you concentrate on as the one written in descending order. We can write this correctly in two ways. For example, if we concentrate on the variable x and have its exponents written in descending order, we would start with x cubed, since it is the highest, largest degree. The next one would contain x squared, and that's the one over there. That's 7x squared y. The next one would be written with x, which is minus 3x y squared, and the last one is minus 4y cubed. And that is written correctly. In the other order, simply requires that we write minus 4y cubed first, followed by minus 3xy squared plus 7xy, and finally plus x cubed. These are all equal to each other and written properly. The next topic is to add and subtract monomials.